FRQ number 12. The graph of the continuous function f consisting of 3 line segments and a semicircle is shown above. Let g be the function given by g of x equals the integral from -6 to x f of t dt. So part A, asking find g of -4 and g of 3. So we're just going to plug those numbers right into there. Oh, there. -6 to -4 of f of x dx equals, and then we just look on the graph for the area, -6 to -4 over 2 up 5 is 10 divided by 2 because area of a triangle is 5. So that's first part there. The second part, g of 3 equals, same thing, integral -6 to 3 this time, of x dx equals, so from -6 to all the way to 3. So we know that starting with this triangle, it's, let's erase that, over 1, 2, 3, 4, up 5 is 20, divided by 2 because it's a triangle is 10. Let's write that down there. Plus, then we have a semicircle here with a radius of 2, and area of a circle is pi r squared, so half of pi r squared, half of pi r is 2, so 4, r squared 4. And then plus, we have another triangle here, but it's under, so it would be negative. It's over 1, down 2, so 2 divided by 2 is 1, minus 1. So now simplifying all this, we have 9, 10 plus -1 plus 4 pi over 2, or 2 pi. So 9 plus 2 pi. Boom.
Part B, we're trying to find g prime of 3, and so we are given the equation g of x is equal to the integral of -6 to x f of t dt. And so the derivative of that would just be f of t dt. And then to find g prime of 3, you just look at the graph, and at the x point of 3, y is equal to -2.
For part C, find all values of x on the open interval from -6 to 3, for which the graph of g has a horizontal tangent. Determine whether g has a local maximum, a local minimum, or neither at each of these values. Justify your answers. G has a horizontal tangent line when g prime of x, which is equal to f of x, equals 0. And f equals 0 when x equals -2 and x equals 2. It is not equal to 0 at x equals 6 because it's an endpoint, so it's only equal to 0 from the right and not the left, so it can't be a local max or min. At x equals -2, g doesn't have a local max or min because it doesn't change signs there, but there is a local max at x equals 2 because when you look at the graph, you can see that G will have a local max because f changes from positive to negative there.
Now for part D, we have to find all the values of x on the interval for which the graph of g has a point of inflection. Now, to find the point of inflection, we need to find where G prime has a change in its sign. And we know that G, oh, this is so hard to do with the mouse. Oh no. We know that G prime equals F. So we just need to see here on the graph where by which values it changes from positive to negative or negative to positive. So we're going to look here at -4. You can see that it's increasing and then decreasing. So at -4, there's a point of inflection. And then we look here at -2. You can see that it's decreasing and then it's increasing. So there's a point of inflection at -2. And now the harder one to see is here at 0, because we can see here that it's increasing and then decreasing. So there's a point of inflection when x equals -4 x equals -2 and 0.